Today we're doing 10-1 Part 1, Radical Expressions and Functions. Radical expressions are what most people think of as square roots, but radicals pertains to more than just square roots. It would be cube roots or the fourth root or the fifth root. So instead of just calling these things square roots, we call all of the different types radical expressions. And so we're going to do the first three objectives: evaluate square roots functions, and find the domain of a square root function. That's what we're going to be working on today. So let's move down here and talk about what the heck a square root is. The square root symbol looks like this, or this one down here. And most of you have seen the square root symbol, so this shouldn't be anything new. You might not know the names, or maybe you've seen it but you don't remember the names. The number underneath the square root is called the radicand, and the symbol is called the radical sign, and then the whole thing, the number and the symbol, is called the radical expression. And this one would be a square root. If we had a number up here right in the little v of the radical, if we had a number 3, it's cube root. If we have a number 4, it's fourth root. Number 5, it's fifth root, and so on. So let's look at a problem with square roots. Or should I say, let's look at this first before we look at the problem. It says, in general, if b squared equals a, then b is the square root of a. So this number, any number that we can square that makes an a, makes another number, then b is the answer to the square root of that number. That's how the square root works. So the square root of 25 equals 5 because 5 squared equals 25, and 5 would replace the b up in this formula. And 5 is positive. Is that what this says? And now the square root of 100 is 10 because 10 squared equals 100, and 10 is positive. The symbol negative square root is used to denote negative square root of a number. For example, negative square root of 25 is negative 5. And negative square root of 100 is negative 10. So when the negative's in front, all you do is you take the square root and you put a negative in front of your answer. Now let's do our first example. Example 1. It says evaluate the square root of 81. Well, what you're thinking of is what number times itself would make 81. And most of you understand square roots and know this. 9 times 9 makes 81, so that means 9 squared is 81, which really makes the square root of 81 9. And that's because 9 squared is 81. Now b, it's the negative square root of 9. All we got to do is worry about the number. First of all, the negative will just get tacked on at the answer. The square root of 9 is 3 because 3 squared equals 9. And so this one would be negative 3 because of the negative out front of the square root. And c, if you have the square root of a fraction, that's equal to the square root of the top number over the square root of the bottom number. So you can split them up and do each square root separately. And so the square root of 4 is 2 because 2 squared is 4, and the square root of 49 is 7 because 7 squared is 49. So we get 2 sevenths. In D, the way D works, just because it's a decimal, it's really similar to just taking the square root of 64. We know the square root of 64 is 8 because 8 squared is 64. So we've got 8, and now we got to figure out the decimals. Well, if we put 0.08 times 0.08, that would make 2 zeros. It'd be 0.0064. So our answer is 0.08. And if you have a calculator, you can just put it in the calculator, obviously, and that would give you the answer. But that's how you figure it out without a calculator. So if I take 0.08 times 0.08, I would get 0.0064. Now, if you have addition in part E, if you have addition under a square root, you can add underneath the same square root. So I can add 36 and 64, and this is going to equal the square root of 100, because that's what 36 plus 64 is. And then I can take the square root. The square root of 100 is 10. If they're separate, like in F, I can't add the two separate. You can only add square roots, we'll get into this in a later section, if they have the same square root, if they're like terms almost. So this one, we could take the square roots separate. The square root of 36 is 6, and the square root of 64 is 8, and then we can add the 6 and 8, which gives us 14. So try the checkpoints. Pause here, try them. Should be really quick, and then when you come back, play it again. I'll give you the answers. Okay, checkpoint 1. A is 8. B is -7. C is 4/5. D is 0.09. E is 5. And F is 7. Let's go on to example 2. Example 2, it says, for each function, find the indicated function value. So they want us to find f of 2 in this first one, which means we're plugging in the 2 for each of these x's. And so what we get is f of 2 equals the square root of 5 times 2 minus 6. And we're just going to evaluate that. Underneath the radical, we can multiply and we can subtract. So we get 5 times 2 is 10. It'd be 10 minus 6, which would be the square root of 4. And that is 2. Let's look at g of x for part B. G of x equals negative square root of 64 minus 8x. And they want us to do g of -3. So we're going to take -3 and plug it into this x here. And we're going to find g of -3. So g of -3 equals -64 minus 8 times -3. And again, underneath one radical, we can multiply and we can subtract. We're going to get negative the square root of 64. And we got a -8 times a -3. That's going to be a plus 24. Well, 64 and 24, that's the negative square root of 88. Well, 88 is not a perfect square. So if it's not a perfect square, we're still going to get an answer for it. We're just going to get an approximate answer. For right now, we'll plug it in the calculator and take the square root of 88 and get negative 9 point, and we'll round it off to 38. Negative 9.38. Pause here, try the checkpoints. When you come back, I'll give you the answers. Alright, in A, the answer is 4 for checkpoint 2. In B, the answer comes out to negative square root of 24, which is approximately negative 4.90 if you rounded. I think it comes to 898 or something like that, so we rounded up to 4.90. Let's move on to example 3. It says find the domain of the square root of a function. We've done this before. We did the domain of fractions when the x was in the bottom of a fraction, and I think in my example I did show you how to do the domain of a square root, and it didn't come up in those problems, but it's coming up now. So if you remember, there's something you got to remember. You got to remember about square roots. Is that we cannot we can't take the square root of a negative, and I'm just going to use the negative symbol, of a negative number. And I'll use the number sign. Can't take the square root of a negative number. You got to remember that. And so what we are limited by in our domain, and it doesn't look like a take. Here, let me fix this. Take. What we're limited by a domain is what number we plug in for x that's going to make a negative. Or the other way we can think of it is, underneath the radical here, this 3x plus 12, it has to be a positive number. It has to be bigger than 0. That's what positive means. So I can take this 3x plus 12 and set it greater than 0. And I can solve the equation just like that, or not. It's an inequality now. It's called, not an equation, but I do solve it just like it's an equal sign. And I would subtract 12, and I'd get 3x greater than negative 12, and I'd divide by 3, and I'd get x is greater than negative 4. Well, that means negative 4 is the biggest number that I can use. Well, I'm sorry, is the smallest number that I can use. And so my domain is with the fancy brackets again, x bar, and this is what I use for my domain. X is greater than negative 4. So any number that I use that's bigger than negative 4 is going to work. Now, how that looks like in a graph, since we did graphing last time, it would be a square root graph that starts at negative 4 and goes up like that and that way. That's what that would be the domain. So if we had a picture of it, would be x is greater than negative 4. It'd be all the numbers greater than negative 4 that would work. Because remember, square root graphs stop. Okay, this square root graph would stop right here and just go this way. There's nothing on this side that works. So my domain is just from negative 4 on. When you're done, now, do you have to show me this picture every time you do this? No. But I will say in your homework, you're going to be matching the domains up with pictures like this. So try checkpoint 3, and you don't have to show the graph, but pause here, try checkpoint 3, and I'll give you the answer when you come back. The domain, then, for this, with my fancy bracket, is x bar x is greater than 3, and another fancy bracket. That's all we're doing for part 1. I will give you your assignment in class.